following question was asked from TOC, Theory of Computation, and the topic is regular expression. The question was asked for 1 mark, and the question is as follows. Which one of the following regular expression is equivalent to the language which is accepted by the DFA which is given below? So this DFA is given to us, right? And if we want to make a regular expression for this particular given DFA, then we need to match that out of this A, B, C, D, which of the following is matching with this, correct? Now here you can see there is a self loop on this. So let me make it a Q1 and let me make it a Q2. So on Q1 we are having 0 as many time as we want. That is 0 star will be the first part that I should have, correct? So 0 star should be the part that I should have. So as of now I can cancel option D. Now if you can see, if I want to reach to the final state, then I need to run this loop. So there are further possibilities that after getting as many zeros as I want, I can directly take single time 1. So minimum string is 1 that is required. Minimum string is 1. So here if you can see, option B is not matchable because minimum string that is generated by this DFA is 1, which is not possible using B. Because even though if it is not going to take 0 from here and here, 1 every time will come. Here it is not so. So just cancel option B also, correct? After that, if we are making the cycle, then what kind of cycle is possible? I can take here 0 as many time again as I want. That is, I can take 0 star as many time as I want. Apart from that, I can rotate the cycle of 1 0 also. 1 0, 1 and 0 star. This 1 is 1 time and this 0 star is as many time as I want. It means that after that, if I want, I can rotate this string 1 0 as many time as I want, but it is not compulsory. It is optional. If I want, then I can do like this. And again, if I want to reach to the, because here it is not ending, it should be ended at the final stage. So again, 1 should be there. So ultimately, I can convert it like 0 star 1, and these are optional. This is compulsion. So I can write 0 plus 1 0 star 1 and whole star. So if now I am going to match it, option A is going to correctly matched. So option A is the correct regular expression corresponding to this given DFA, right? So it was asked for 1 mark and very easy question. I hope it is clear. The following question was asked from Theory of Computation. The topic is non-deterministic finite automata with epsilon transitions. The question was asked for 2 mark and the question is as follows. Let M be the 5-state NFA with epsilon transitions as shown in the diagram below. Which one of the following regular expressions represents the language accepted by M? And 4 options are given. So here if you can see, I am having 2 final state. This 2 is a final state. This 5 is also final state. This 1 is a non-final state here. This 4 is also non-final state. This 3 is also non-final state, right? So given machine is going to accept all the zeros because here epsilon. So it is going to accept all zeros. That is 0 star. It is going to accept all the zeros, right? Because we can move, we can go to the epsilon directly here. It is non-final state and it is final state directly with the epsilon transition. It will accept, and here also if you can see epsilon is here, right? So from any choice, we can reach to the final state either here or either here. So the given machine will accept all the zeros. So 0 star will be there. After that, if you will see, we can reach to the final state 5 by either, if I am going to move from here, then it will take either 0 into 0 0 star, right? 0 and thereafter 0 0 star, and I can come here 0 0 0 star because 0 is compulsory. And after that, if I am again rotating like this, so in this rotation, this 2 0 will become, but this is optional. That is why this clean closure is paused, because they are optional. If required, then we can do, and after that directly using epsilon we can come here. Or if I want to come through this path, then epsilon is here, nothing is there. So here this 1 is compulsion. So if this 1 is compulsion, so I can write or. So either I can take 1 as a direct, because 1 is required obviously, without 1 we cannot go, or 1 star, this is compulsion again, because after taking this 1 we can directly reach into this final state, but it is our choice if we want to rotate according to the need. Then 1 star we can make a loop of it, correct? So if you will see here, then option D is by default I can cancel. Why? Because 0 plus is mentioned here, and as you can see that it is not the possible one. After that, if you will see here, if you will see here, then if we are going to rotate with 1 also, if we are going to rotate with 1 star also, it is possible, because it might be the thing that we are taking 0 from here and directly we are coming here with the help of epsilon. So 1 star is also our choice. It depends. It depends. If required, then we can take. Thus, what I can say, that I need to take 0 star anyhow. I need to take 0 star anyhow. Thereafter, I need to take 0 star. So clearly we can see this is not possible. This is not possible. So directly I can see option B is the one, because it is only having 0 star plus add them. So 1 is compulsion. Thereafter plus this 0 was in compulsion, and then 0 is having optional part, and this 1 is in optional part. Thus option B is the correct answer for this gate question. I hope it is clear. The following question was asked in theory of computation from the context free grammar, and the question was asked for 2 mark. The question is as follows: S derives AS, S derives ASBS, and S derives C. So let W belongs to L of G. Let NAW, NBW, and NCW are denoting the number of times A, B, and C are occurring in W respectively. Then which of the following statement is are true? Correct? Then if we want to answer this particular question, we need to derive the tree like structure, and based on that we need to analyze it. So for that, if I am starting from S, then I can make a tree like this AS. In any time, at any particular time, if I want to end up, I will end up it with C, which is a terminal part here, right? So we can only terminate it with the terminal C. This is so now. After that, if you will see, one more tree is possible, that AS, and if I want to further it derive in some other way, it could be like this: AS, BS. And if I want to end up, I can end up it with C, or if I want to continue it again, if I want to continue it again, I can continue, or I can end up it like this. And further there are two choices, like this and like this. So just generalizing the things, the option A is number of A is greater than number of B. What it is saying, the number of A is greater than number of B, but it does not necessary that number of A in the string will be greater than number of B. Whereas if you can see that, if I, because here if you will see there is no existence of B, but if you will see here, then number of B is greater than number of C. Number of B is greater than number of C minus 2. So if we are going to subtract 2 from the how many times C is occurring, the C will be minus 1, lesser than B, because here there is no existence of 0. A is occurring 0 time, A is occurring 1 time, B is occurring 0 time, C is occurring 1 time. And if you will take this example also, then A is occurring 2 time, B is occurring 1 time, and C is occurring 2 times. Correct? So one thing is clear, that C will be always 1 time more than B. Thus I can say option C is the correct one, because C will be every time, because every time if I want to make a termination of this S, so S will every time terminate with C, C and C only. And every time if it will terminate here, B will not appear, and if it will repeat, B will come once. And if B will come once, C will come twice. So C will be one more time compared to the B. And this rule number C is saying, D is saying that C will be 2 times of B, but it is not so in the both cases. So it is wrong. It is wrong. and option B is definitely greater because we are subtracting the minus 2 from that. In that case, B will be more. Number of times B is occurring will be one more than C. So B will also correct in that case. Thus I can say that option B and option C will be the correct answer for this MSQ question which was asked for 2 mark. I hope it is clear. Just generalize the tree and analyze option by option, right? I hope it is clear. The following question was asked from theory of computation and the topic is regular expression. It was asked as a numerical answer type question for 2 mark. The question is as follows. Let L1 be the language represented by regular expression which is given here, and L2 is the equation which is given here, where W denotes the length of a string W. The number of strings in L2 which is also in L1 is, we want to figure out the total number of strings which are part of L1 as well as which are in L1. Means we need to see the combination now. And if we want to see the combination, first thing I need to check whether the strings are limited or not. So here obviously strings are unlimited, but here the strings are limited. So if I am going to make intersection which is generated by this L2 with L1, limited part will be there. So let me try to do it. L1 equal to B star, any number of time B, AB star, thereafter AB star, AB star ka whole star, right? And L2 is like this. L2 is like this, where W is belong to A plus B ka whole square, A plus B ka whole square. So I can write it like W belongs to A plus B. Any choice we can take out of A plus B, but the condition is that only the length of string will be lesser than or equal to 4. Right? Now L1, what string it will generate? So L1 can generate B star A B star, or it can generate B star A B star A B star and A B star. Based on the equation, it will generate this or this, right? So I just need to check how many number of length it will generate which is lesser than 4, because whatever it will generate, definitely this language will generate. Why? Because this is a universal language. This is a universal language because A plus B ka star, all the combination is possible. All the combination is possible. So we only need to check that how many strings are generating by this which is having length lesser than or equal to 4. So it can generate A, it can generate BA, it can generate B square A, it can generate B cube A, that is for length. So we can validate AB, A B square, it will generate A B cube also, and it will generate B A, right? And B, it will also generate double B A B, and it will generate B A double B also, right? So here if you can see 1 2 3 4 5 6 7 8 9 10, these are the possible strings. 10 strings are possible. So these strings can be formed with this combination. Now I need to check out this combination, that how many strings possible with this combination which is of length lesser than or equal to 4. So from here we can generate this A is compulsory, this A is compulsory, this A is compulsory. So the minimum length generation are A. This is the compulsory strings. This should be generated anyhow. After that, if I include one time B, then A B double A, it will also generated. If I will include this B first, then B A, right? Or I can include B at this position also. In that case, it would be A B A, and if I will include this B at last, it would be A B A, triple A B, triple A B. So apart from this, 1 2 3 4 5, these 5 strings are additionally generating. So 10 strings which is lesser than or equal to 4 length generated by this part, and 5 strings of length lesser than or equal to generated by this rule. So ultimately total 15 strings are there which can be common in L1 and L2, because L2 is universal language, combination of all. So these 15 strings are common among L1 and L2. So 15 is the correct answer for this NAT question which was asked for 2 marks. I hope it is clear.